Welcome. The difficulty level of this video is moderate. Well, today we're going to talk about supercomputing and how supercomputing power is tracked via graphs maintained by a variety of independent organizations. And the reason that's important is the graphs that they maintain tell us about all technological progress and give us as close to a pure barometer as you get in terms of whether technology is advancing at the long-term trendline rate or whether it is saturating. So while supercomputing may seem like an esoteric subject, if you care at all about exponential technological progress and increasing human prosperity, this is definitely a metric that you should check back on from time to time, as we will do on this channel. So there's a website here called top500.org, a very simple URL, and obviously this website has been around for quite some time, but it tracks the 500 most powerful supercomputers in the world at any given time. And it's less interesting to look at individual supercomputers or which supercomputer takes the crown or even which country necessarily has the greatest number of the topmost supercomputers. Instead, what we want to look at are the macro statistics of all supercomputing and tie that back to some economic thought and very macroeconomic technological thought. And hopefully that's what you came to this video to see. So we go to statistics on this website and we go to performance development. So now in looking at these performance statistics, we go down to this chart, and let me explain what these three lines are. The orange is the least interesting because that is the speed or power of the most powerful supercomputer in the world at that time. The horizontal axis are the calendar years, the vertical axis is petaflops per second of performance. The blue line is much more interesting because that is the performance of the last member of the top 500, so the lowest of the highest, so to speak. And since none of these supercomputers have usually ever been number one, you can tell where the cutoff of the list actually is. And you see this flattening that has occurred in recent years. This flattening is in fact the whole point of this video, as I will soon elaborate. But the most important line is the green line, the sum. And as you can see, this is the sum of all of the top 500 supercomputers in the world. This list started in 1993. They put a new data snapshot every 6 months, and this is where we are as of the most recent entry, November 2020. And the sum is also flatlining. It was rising at a certain rate, and by around 2013, it started to flatline. As you scroll further down below, you see the same chart. I don't know why they had to have two in order to put a trend line, but this chart happens to be the trend line. You can see the trend line of the data starting from 1993 and how it's flatlining, as well as the sum, the most important of the three lines, the green one, is also flatlining. Now this is particularly worrisome for a couple of reasons. One, the fact that the bottommost cutoff point is flatlining pretty fast means that the sum is only being somewhat artificially propped up by the topmost supercomputer in the world, which is still making a largish kind of jump. That is being brute forced at tremendous expense of energy, engineering, and other resource consumption. If you were to take away just the topmost supercomputer and the trend line of which organization or which country has bragging rights for being number one for a certain period of time, then the total would be flattening even more, as we see at the bottom. This means that computational speed as a whole is no longer growing as quickly. We are below trend line. We're easily about 10x below where we would be had the trend line still continued, because even this trend line accounts for some of the flattening. That means just to get to where we ought to be, if we go back to the top chart, in 2025, there needs to be a 100x rise in 4 years. Now, why would computing even return to the trend line when we're seeing a saturation? The reason there is a saturation across this, and therefore across all computing, that includes consumer products and anything that an individual would purchase in a store that has computing, is because the existing paradigm of computation derived around Moore's law and shrinkage of transistors and existing computer architectures is just saturated. The memory, processors, and storage are too far apart. Being a few inches apart in a PC means many nanoseconds are consumed in all the instructions going back and forth, which does matter when you're doing that potentially a billion times to get a certain computational job done. It slows down the entire speed of computation. Furthermore, this saturation started to be a problem as far back as 2013, and that's why we have so much missing growth. And that missing growth has translated to saturation of economic growth relative to what it could be. And this does not contradict when I say elsewhere that economic growth is exponential and accelerating. It is, but it would be much better than it is now if we got to a new paradigm of computing. This is also why many of the high-flying tech companies of today will actually see somewhat of a setback because none of them are creating a new paradigm of computing. They're only using brute force tactics to squeeze some extra juice out of old existing computing paradigms, and it's becoming very energy intensive. Supercomputing is energy intensive, and when something takes too much energy or too much money to generate any small amount of incremental gains, that is nature's way of telling you that this paradigm is saturated. You are at best trying to create a faster horses type of setup, and a whole new paradigm is needed. We all know that Bitcoin mining consumes a huge amount of electricity. It actually consumes 1/300th of the entire world's electricity consumption, or about 72 terawatt hours. Put another way, that's as much electricity as an entire country the size of, say, Colombia consumes. And the same is true for all other computing. This is why PCs are not getting faster at the same rate as they were from the 90s all the way up to 2013. And this flattening of technological progress has percolated throughout the entire economy. Now, there's still enough technological progress to consume the trillions upon trillions of monetary creation, which is to say QE from central banks, for lack of the most accurate term. Some people call it money printing. There's still enough technological progress to consume all of that. But if we were just at this trend line, all computation would be maybe 10x faster today than it is right now, and many trillions of dollars more of money could be metabolized by the global economy, and there would be that much more human prosperity. Now, fortunately, I am involved in a company that is set to create this new paradigm of computing with a little bit of luck. We have thought through all these problems in considerable sophistication, and I will be revealing more about that company as it comes out of stealth and my participation there becomes more public. But at the moment, this is why computational growth is saturating. And this is much more than just Moore's law. This is a saturation of the concept of putting more and more cores into a small space, spending more and more energy to brute force everything, as I've been speaking about. It is really a major historical turning point that is imminent, because to just revert back to the long-term trend line, there will be a huge and relatively fast burst in computational growth and a huge amount of innovations downstream from that. And that is why this trend should be looked at every 6 months or so when they update the chart. I hope you found this video informative and it was clear as to how something esoteric like supercomputer long-term performance trends do in fact indicate a lot to us about how quickly technological progress is occurring, where we are in terms of keeping to the trend line or falling below the trend line, and how this relates to economic progress also flatlining from the trend line, or at least underperforming relative to the trend line because of the connection between technological progress and economic progress. If you have some questions, please insert those in the comments below. And thanks for watching.